Welcome to the Gold Rush Robotics GitHub workshop. We are Gold Rush Robotics. We're a student organization here on campus for undergraduates who want to do robotics-related activities. Anything related to that kind of thing we want to support. And part of that is that we want to do more of these type of workshops where we invite anyone who has any interest in whatever topic we're talking about to come, and we will do a 45-minute to hour-long workshop on some topic. And this day's topic is GitHub. So Philip here is going to teach you all how to use GitHub. He knows how to use GitHub. I know how to use GitHub. A couple other people in the room know how to use GitHub. So if you don't know and you're trying to learn and you're having any problems with the workshop, this is not here for Philip to just lecture at you.
Yep.
It's here for you to learn. So if you have questions or need help, a couple of us can walk around and help you with it. Just let us know and we'll come assist you. Anything else? All right, take it away, Philip.
Okay, so out of curiosity, who here has heard of Git and GitHub before? Awesome. Who here has used Git or GitHub before? Awesome. Who has a GitHub account? Awesome. Who has GitHub Desktop installed? Awesome. Sweet. Okay, that will make our lives a lot easier. The goals for this workshop, by the end, you should be able to use Git and GitHub to manage your own projects, as well as being able to clone and collaborate on other people's projects. So another thing, I like big words. I love them. I'm not great at remembering what big words are common and what big words aren't. So if I ever say a word that doesn't make sense, raise your hand. You're probably not the only one it didn't make sense to. Especially with Git, there's a lot of very Git specific terms that have a very specific meaning. So if I say one that you've not heard before, ask. That's what this is for. So Git primarily is version control software. That means you can have multiple versions of it, and it makes controlling that easy. So if you've used Google Docs is a version control software. You know how you can hit the history button and you can see all the various changes? That's very similar to what GitHub does, but GitHub does it for everything. So important features for version control to have, Git has them all. You can back up files. You can revert to old versions. You can collaborate with other people. And Git and GitHub have another thing that's super nice, which is branches. And I'll talk about those a little bit more in a second. In addition, it's also local, which is awesome, because that means when I go on my 12-hour car ride and don't want to have a hotspot, I can work, and then when I get to where I'm going, I can just push it up to a remote hosting site. It's often associated with code. That's where you'll hear it the most. It can be used for anything else. We've used it for CAD before. It's not great at doing CAD, but it works. It can be used for PowerPoints. It can be used for your science project. It can be used for a research paper. Anything along those lines, it can be used for that kind of thing. I actually so the way that Git works under the covers a little bit is you have your code, right? So we've got a file. Let's call it a.txt. And that has some stuff in it, right? When you make a commit, that's the first Git terminology. A commit is basically just a snapshot. So when I make a commit, the first commit is just going to say plus a.txt and then plus each of the lines because they're brand new. That goes in one commit. Then let's say I go and add another line. The next commit just says plus the new line. So then what Git can do is it knows where it started, which is absolutely nothing. It can go through every commit in your tree and add those changes and get to where you are now. Does that make sense? So at the bottom of the list there, branches. Notice this kind of looks like a tree with just one thing on it. The thing you can do is you can have different versions, different branches, where you change different things. So in this case, we added this particular squiggly line. In this case, we added that particular squiggly line. The really awesome thing is that then we can do something called a merge commit, which is you merge the branch back in, and then it'll build all of this, everything over on this side, and then everything underneath as well. That's just kind of a visual diagram of what's happening. We'll step through how it works later. But does that make sense? Yeah.
So you've got the two branches.
Yep.
Say like the first commit is on like line 5, and the branch commit is also on line 5. How would the merge handle that?
Yes, that's a great question. So what happens when you try and modify the same thing in two places is you get something called a merge conflict. And basically GitHub goes, hey, I don't know how to automatically handle this. And so it spits it back to you. And if you're using a GUI like GitHub Desktop, it'll spit it back to you in a very user-friendly, very easy to show way. I might demo Git merge conflict later if we have time. And basically you have to tell it either take this one, or take this one, or take both and put them in this order. So one becomes line 5, one becomes line 6. And the fun thing is whether you actually declared a branch or not. If you're working with someone else and they make changes and you try and pull it back in, you have to do a merge. Because you basically have the same thing as a branch with the remote and your local. And I'll explain that more just a little bit too. So then that's what Git is. Oh, it's also industry standard. Went through all that. So if you're using just Git, just on your machine, you make your changes, you add those changes to a commit. That's another Git specific word is git add. And then you git commit those messages, which is where you take that snapshot and it saves it to the Git file. So then GitHub, they're often used very synonymously. They are different. GitHub is an online repository hosting. So it is probably the standard for the way to host a Git repo online. You can have repos that never go online and are just on your local machine. Yes, sorry. A repository is the tree of commits. So repo, repository, that's one tree, one project. That's typically how people organize it, is by project. So like, for example, we have one repository that is our robot code for this season. It allows it, so because it's online, makes it super easy to share. Home to almost all open source projects. Some of them will use random other ones, but the standard is to live on GitHub. It also has a bunch of cool tools. So it's got CI/CD tools, team project and management tools. It's got issue trackers. It's got cloud computing for you to use. It has a ton of tools. We are not going to scratch the surface of what GitHub can actually do for you or what Git can do for you, but we'll barely dip into the wave there. So to add GitHub to our previous Git workflow, the previous one is just make your changes, add it to a commit, and then commit it. With GitHub, we want to make sure that we pull down the online changes so that we're up to date with online. Then we make our changes, we add it to a commit, we commit it, and then we add a git push. So git push is another Git terminology, and that basically means push all your local commits up to the origin. And then you can add other GitHub tools. So I'm going to walk through. We have two options. I made some slides, or I can walk through it in the GUI like without without the slides? Which one would people prefer? If you would prefer me to walk through it right now, raise your hand. Okay, where'd you get lost? Yeah, I'll walk through it. I think that'll make more sense than the slides. Yep. Okay. Don't worry about that. Okay. So if you open GitHub Desktop and you've never used it before, did you have questions? Sorry. All right, so we are going to create a new repository on your hard drive. So when we click this one, is that big enough? Can you read what's on there? So this is what it looks like. So when we're creating a repository, we have a couple options. So name is what it will be called when you publish it up to GitHub, and what it will be called in a folder on your local machine. Description will go ahead and populate the README, which you see is mentioned down there too. So README is a super helpful thing that GitHub really kind of introduced and pioneered, which is that every single repository should have a little text blurb explaining what it is, how to use it, how to install it, all that kind of stuff. So that's typically all caps README, typically readme.md. If you open a GitHub page, then GitHub will go ahead and render that and will show it to you. Because that's kind of their system they pioneered. Local path, that lets you pick where on your computer it is. It will default to documents GitHub. I'll probably do myself there for this just because it's the default. Then git ignore. So that's another fancy Git term. In your git ignore, it's a way for you to tell it to ignore certain files. So let's say you have a file that has an API. That's bad example. Let's say you have a file that has your passwords in it. What? Credit card number, password, any kind of sensitive information that you don't want to be publicly available on the web. You can add that to your git ignore file, and it won't try and push it up. Because you'd hate it if you accidentally pushed your credit card number to GitHub, and any random schmo could go and find it and charge you thousands of dollars. So there's default templates. That's not actually the thing. That is the picture. There's default templates. There's a bunch of templates. So what the templates are is basically it knows some things about some languages. So like, for those of you who have used Java, which is what all the CS classes use, when you go to run a Java, it compiles to so you've got your .java files and you've got .class files. So if you were to select the Java menu here, it would ignore all of your compiled .class files just to make your Git cleaner. That probably did not make much sense. Did that make enough sense to everyone else? That's fine as well. No. Yeah. Licenses. These matter a lot when you're looking at other people's code. GitHub also really pioneered this, which is in your Git repository, have a file that is just named license that basically contains what the license is for your code. So above the line are the three like default ones. Below the line are some more like specific ones. If you are making code for a project that you intend to be open source that you don't intend to sell or monetize, just like the MIT license. It's a great license that gives you and other contributors plenty of power and no legal problems. Yes. So a license is who legally owns the code and what other people can legally do with it. So like I'll make it with an MIT license and we can open it up, and then I have to give it a name. I made a test one earlier, and I think I forgot to delete it, so I'm going to. And then I'm going to give a description to show where that shows up. If I can type. So then if we create it, we'll go to this screen. This is the default GitHub desktop screen. From here, there's a bunch of cool stuff we can do. If we wanted to go back to that other screen, we could make a new repository by clicking on the repository dropdown and then the little add button. Typically, the first thing that we want to do is if we're not planning. So right now, this is a local Git repository. If we want it to be up on GitHub, we have to hit this little publish repository button. So I'm going to click that, and then we have to make sure, just accept the default things. You can turn on or off, keep it private. It doesn't really matter. You won't have an organization option. And then publish. Whee! So now this repository exists on GitHub as well. So if I come to Safari and I get into GitHub, then for most of you, it will probably show up on the side here. If you don't do a lot of work in repositories, then making a new one will instantly pop it up into the top. I make enough commits on average a day to these other repositories that a new one means nothing to GitHub. So if I come here and click on my profile, then we have a list of all the repositories that I have. So this is where the one that I just made showed up. So this is what it looks like if you look at a default repository on GitHub. Up here are the files that exist in that repository. And down here is the rendered readme.md that I was talking about earlier. So you see how it has big and bold the name of the... There we go. So it's got big and bold the name of the repository, and then it's got my little description down there underneath. It also has this license file that looks like legalese. It is very short, the MIT license. It basically says, I'm not charging anything for it. You're free to modify it. If it doesn't work, don't sue me. Which for most open source projects is exactly what you want. If you care about legalese, we can talk about different kinds of licenses. But whenever you go use someone else's code, you always want to look for a license. If they don't have a file called license or something along those lines, then it's assumed to be the most restrictive license available, which means you can't use their code, you can't sell it, you can't do anything. Which makes sense. But most big repositories will have a license, and it's always good to just double check what that is. So some other things that we can see from this view, we can see what the last commit was, which was the initial commit. We can see who it was made by. It was made by me. We can see how long ago it was. We can see the hash of the commit. Doesn't really matter. And we can see how many commits are in the tree. So right now, one commit is in the tree. There's also a whole bunch of other settings and other things you can poke at. We might poke at those a little bit later. But yeah, so this is now your own repository that's on GitHub. Awesome. If we go back to GitHub Desktop, there are a couple options. So instead of going to GitHub like we did earlier, I could have just clicked this button, just view on GitHub, and it takes you right to the repositories view page, which is an awesome feature that I didn't know existed till just now when I read that button. Then we've got Show in Finder, or Show in whatever the Windows one's called, File Explorer, which takes you right to it. You'll notice that there's some hidden files. If you don't know how to show those, don't worry. But this .git folder is what stores the entire repository information, in case you're curious where it lives. And the .git attributes stores some of that as well. So if we're sitting here Is everyone here on Windows besides no, you're on Mac. So on Windows, when you're in File Explorer, you can right click and you get like a new text document option. Mac users don't have that, which is kind of annoying, but it's fine. So I personally, since I have, so this is a big reason for .git ignores. These like annoying little binaries that happen when you open them on your computer. No one wants those. But so if I go and open where this put it what documents, GitHub Workshop 2. So this is Visual Studio Code. It's a integrated development environment. It's my favorite. If you don't have it, you can make a text file using TextEdit and save it to the location or any other text editing program. Yep. Yep. Yes. If you're on Windows, that's nice and easy. You can just right click and say new text document. So you can name it whatever you want. I'm going to name it philip.txt. And then, as a good programmer, I'm going to start it off by putting just hello world in there. So then if we come back to GitHub Desktop, you can write anything in this file. It does not matter. This is just to show how it works. So when we come back to GitHub Desktop, you see how it says 2 change files on the side? The .ds store is a Mac thing. Don't worry about that. But this philip.txt, when we click on it, see how it shows us exactly what changed? This is showing us this view. See how except it's got real things instead of squiggles. But that is analysis. So this is showing us what we're about to commit, what changes we're about to add. So you see over here where we've got these checkboxes. I didn't check .ds store, but I did check philip.txt. So this is how you add in GitHub Desktop. Now we're talking about git add. Oh, can you not see that? That work? So these checkboxes, if it's checked, then you've added it. If it's not checked, you haven't. Then down here, we have a title and then a description for the commit. Now, if we look, GitHub Desktop is really smart. It figured out that all we really did was we made this file. So it auto-suggests the title, created philip.txt, or whatever your file is named. That's probably a perfectly reasonable commit message, but you can also type whatever else you wanted in here. The description, again, if you want a longer description of what you did in that commit, that's a great place to do it. But once we're happy with those two things, we can say commit to main. So now it's committed. So this far right button, this happens to be a contextual button for GitHub Desktop. It changes depending on what your current state is, which is really nice and really helpful. So like earlier, it said publish repository. Then we clicked it, it changed to probably say fetch origin. Now it says push origin. It basically, it will change to be what the logical next step for you is. Do you know how we talked about after you add and commit? Since we're using GitHub, we want to push. So that's what this button right up here does, push origin. It pushes it up, and there we go. Yeah.
So when you're committing in GitHub Desktop, we already placed the file, so what is that actually doing for us? When we commit, when we just hit commit.
So when you push the commit button, what you're doing is that you have made some changes on your local file system. You have gone into the repository, you've done something. What the commit button does is say, hey, I like these changes. I want to stick with these changes. I want to add them to my project. And hitting the commit button will go tell the .git file that, yes, these changes are something I do want to keep. And every time you hit that commit button, Git will store another snapshot of your project at that point in time. So when you make multiple changes over multiple consecutive days on a project, you want to press that commit button every single day so that you have a snapshot of your project on every single day. And if I do a day's worth of work and I don't like it at all, and I think, wow, everything I did today was terrible, I should just revert back to the other one, you can go back to that previous commit, that previous snapshot, and get those files back. That's part of the benefits of version control that GitHub offers you.
I'll try to do in just a little bit, but what were you going to say?
That's stored locally, correct?
Yes, until we push that push origin, that was stored locally. Once we said push origin, that pushed it up to GitHub.
Yeah, there are two main verbs that deal with getting stuff from your local to a cloud storage thing. That is push, that is pull. So pushing takes your local and says, I like what's happening here. I want it to be stored on the cloud so that if my computer ever dies, I can get it back. So you're pushing from your local storage to the cloud storage. And then other times, maybe you're on a different computer, not the normal computer you've been working on with this project, but you have it saved in the cloud, you can do what's called a pull. And that verb pull will pull from the cloud storage down to your local computer so you can have the files that were once stored on cloud on local.
So in this case, we're using GitHub as our cloud. We can push up or pull down. So those are our synchronizers, is the fancy. Can't wait to say that. Does that make sense to people? Until we pull, we only have this on our local. Until we push, GitHub doesn't know about what we changed on our local. So if you've made a change, even if you've committed it, and you say, hey, go look at this, but you haven't pushed it, they'll be looking at old code. Does that make sense?
The analogy to pushing is like submitting your homework to your professor.
Yeah.
You can still make changes up until the point you submit, and then when you submit it, that's your push.
Yeah.
And you can continue to make multiple commits and multiple pushes after the fact, but that's what the GitHub does.
Yeah. And the fun part is, let's say Varshy's working on the revolver. So that's the thing that stores our marshmallows on computer A. And I'm over here on computer B. We can both talk to and from GitHub, and everything plays nice. As long as, yeah, I'll talk about that. So, yeah, if we go look at GitHub now that we've pushed, and you might have to refresh it, but you should see your TXT file. You know, it's not a lot, but it exists. That's stuff you typed directly that is now on GitHub. Awesome. I am going to pull my other thing back up real quick because I had a yay GIF in my slideshow. Congratulations. We now have stuff up on GitHub. So yeah, so let's say, okay, I'm done saying hello to the world. Now I want to say goodbye to the world. Right? I come back to GitHub desktop. Oh, I made changes to philip.txt. So you notice how it says we changed line 1. We switched hello, which are highlights in red to say we deleted it, and it shows goodbye has been added with green. See how that changed you really clearly shows you what happened? Awesome. We love being able to clearly see what happens. So if we do the same thing, so the default message is update philip.txt, not super useful in this case. So we'll call it something else. Switched from hello to goodbye. Right? And then we commit it to main. We push it up. Awesome. Now if we come back to GitHub, it says goodbye. Awesome, right? Does that make sense to everyone? Did I go too fast? Awesome. So now we're thinking about it. Now in this case, it wasn't a huge change, but let's say we did make a huge change. Let's say I did a day's worth of work. All it was complete garbage. I really want to be saying hello to the world again. I don't like leaving. So I can come here back to GitHub Desktop. I can click on this history tab. So this history tab shows us our entire tree. So you see how it says initial commit, and then create philip.txt, and then switch from hello to goodbye? See how we have all three of those stacked up like that? And if we click into them, we can again see the changes, exactly what changed. So then, we didn't like the thing that happened in this one. So you see this revert changes in commit button? That's right-clicking on the commit in the history mode. We now have this revert commit that has been added that undoes every change in the other commit. If I push this back up, there again. Back to hello. Now the awesome thing about doing it as a revert commit is that means everything is still there. So let's say 2 days later, I decide, no, I actually really do like saying goodbye over saying hello. This is a simplified example. But I can come, I can revert my revert. And I can push that back up. Now it's goodbye again. Does that power kind of make sense, what that's giving us? It's pretty cool. We also can see that in GitHub. So if you're looking at someone else's code, you can go and look at all their recent commits. All the commits, actually, if you care to. Yeah. That's probably that's a really, really nice feature, is that super easy and clean reversion. Because it's saving just the changes, it's really easy to make an opposite of changes, right? Everywhere you add, you delete. Everywhere you delete, you add. So let's see. We've got 20 minutes before wait, did I say 45 or did I say an hour? We've got 7. So would people rather me show branches, or would people rather me show a merge conflict and resolving that? Merge conflict? Merge conflicts? Okay, cool. We'll do that. So the way that I'm going to do that, and this is also going to show something else. So the way that I'm going to do that is I'm going to clone this repository again to a different location on my computer. Don't do this. This is purely for the example. But it will show us how to, you can follow along if you want, but for any other project, only ever have it once on your computer, because otherwise it will become a nightmare, as I'm about to show. Yes, that's what I was about to do. So clone is the initial step. So you see how we have the cycle from GitHub to your computer, where you pull, then you push, then you pull, then you push. The initial, so it's up on GitHub, it's not on your computer. In order to get your computer to know that it exists on GitHub, you have to clone it. Exactly. Now, there is a distinction. If you just download the file, it doesn't download that .git folder. So it doesn't have any of the history. It doesn't know how to push. It doesn't know how to pull back down, which is why we want to clone instead of download. But it is essentially downloading the. So with GitHub Desktop installed, we actually have a really easy way to do this. We click on this little like code button here. And right here, there's open with GitHub Desktop. And then if you have a Mac with security, it'll say, oh, it's going to fuss at me, isn't it? So GitHub Desktop is preventing me from doing the stupid thing that I'm about to do. So instead, we are going to try and see if we can do it by hand. It's not going to let me. If it's not going to let me, that's going to be impressive. Okay, here's the problem. So you'll have to select a different location. But when I do that, so I put it into my projects folder instead of into my desktop folder. Which, that's a computer organizational thing. That's what I like, having a projects folder. I recommend it, but that's up to people. Anyway, so I put it in my projects folder. I had to copy this HTTPS clone link and do it manually because GitHub Desktop tried to prevent me from doing the stupid thing that I'm about to do. Normally, you just press the open in GitHub Desktop and it will work no problems. So then I press my clone button. So since it's not a very big repository, it did not take very long at all. So now if I open this in my external editor, so we now have two exactly identical copies of this repo. So in this new one, we're going to show normal behavior first. So Philip 2 was here. Right? We come back to GitHub Desktop. Oh, because it switched to a carriage return. Yep. So we just changed Philip.txt. Update Philip.txt. Not a great name, but whatever. We've committed. We push. We switch to the other repository. We say fetch. We say pull. Now here, it's updated. So they match again. Yeah. So fetch is a refresh. GitHub Desktop will do it automatically every 5 minutes, I think is the default. So normally you won't have to worry about that, but because I'm trying to demo and I don't want to sit around waiting for it to turn to pull, I just clicked fetch. So now let's make a change on both. No, it was Philip 2. And for a long time. Right? We've now changed both on the same line, same file. So I come here, I say, yep, that's what I want. Oh, wait, oops. Philip 1, commit to main. I switch back. Actually, let me go and push. I come here, I push. Cool. On this side, all good. Come over to this other one. Philip 2 stayed. And we say commit. Then I try and say push. Newer commits on branch. So it gives us an option. Fetch. Okay. Pull origin. Oh no, there's a conflict. Oh, is it not going to let me? I thought they had a nice one. Okay, whatever. So it now says open. either in default program, open in Visual Studio Code for me because I've got that installed, reveal in Finder, or just directly use the modified file from the cloud, or use your modified file. In this case, I'm going to open it in Visual Studio Code. So you see how we've got head current change. So that's what's coming in. And then we've got incoming change. That's what was on our machine. So I can say accept both changes and just stack them like that. And then I save. I come back here. I say continue rebase. And then I can now push. So the biggest way to avoid that is to make sure that you fetch and pull before you begin any work. Because if you are like 4 commits behind, the odds of you accidentally touching the same line as one of those other 4 commits is really high. If you are 0 commits behind, the odds of you touching the same line as 0 other commits is 0. So that's the easiest way to avoid them, but they do occasionally happen. And when they do, the nicer of an editor you have, the easier it will make your life. So you just saw how Visual Studio Code had like the accept incoming, accept both, accept head, accept neither buttons, just ready for me. If I was doing it, here, let me create another conflict. Yeah, and then I come on this one, and I commit with the horrible message, and I push, and I come to this one, and I commit with a horrible message, and I try and push, it fusses at me, I try and fetch, I try and pull, we get a problem. I will open it in the most horrible editor possible. So basically, the important thing you need to know is these lines. Can you see that at all, or do I need to make it bigger? Visible? There we go. You can see now? So these lines, where it's like marking head, and then the equal sign is where it changes from the head to your local, and then the like greater than signs, and then the hash. These need to be gone, or else it will still say there's a problem. In this case, we want to merge these. So we want to get rid of this word, and then now those are merged. So I'll get rid of these lines. I didn't mean to get rid of that line, but that's fine. We successfully merged. So when we come back to GitHub Desktop, no conflicts remaining. The way it's checking for conflicts is looking for those like 8 less than signs, those 8 equal signs, and those 8 greater than signs. If you leave those, A, whatever code, PowerPoint, or whatever you're working on will die a horrible, painful death, and B, GitHub will not think, it will say there's still conflicts. So then we can say continue rebase, and then it's all happy. If we go to GitHub at this point, or look at this history, we just did manual merges. So it just shows up as part of our other commit. Now, let's say we made changes that didn't break. They didn't conflict with each other. So on this one, we added a new one. What should this file be called? Tano.txt. And on this one, we make one Fortnite.txt. And then llamas. And on this one, wires. And then we come here, and we're like, okay, we added Fortnite.txt. We added the single line llamas. So we'll commit with the message create Fortnite.txt. Commit that one. We'll push it up. We come over here. Yep, we made Tano.txt with that message. Commit to main. We'll pull, rebase, and push. And it's all happy. There weren't any merge conflicts. It was just a single button, and it worked. So that's the standard behavior with multiple people working with no merge conflicts, which should be most of the time, but occasionally you will hit that merge conflict. Yeah, that was. Any questions? We've got some time. Yeah. Yeah. So the way that I like to think about it. So you have these two pieces of code. These are the code. Get fetch is me going, yo, any updates to the chalk? And you're like, yeah, there's some updates to the chalk. The get pull is me walking over here, seeing the updates to the chalk, and taking those for myself. So a get fetch never changes what's on your thing, but it lets you know about changes to the other side. Does that explanation make sense? Yeah.
So the fetch is just checking.
Yep.
Okay.
So GitHub Desktop will do it periodically for you in the background, just to like go and update and be like, yeah, people have changed things on. Yeah, so if we come here, see how right here there's this fetch origin button? We can push that, there's nothing to fetch. So it doesn't do anything. You can't. Yeah. So GitHub Desktop, if you try and do git pull, it maps it to git fetch, git pull. It turns out so does every single command line ever. The git push, the git pull command is actually an alias for git fetch, git pull. You can do some things to get around that, but it's a mess. So just trust and just let it work.
GitHub will let you do stuff like it will automatically fetch, but it will never automatically pull. Because there are situations where there might be changes on remote or on the cloud that you just don't care about. You don't want to deal with it right now. Like there can be changes up there and more commits. I don't care. Doesn't matter to me. I'm still working away on my stuff here, and I don't want it to accidentally pull and overwrite things that I'm currently working on because I'm working on something completely separate.
Yeah.
So you will always have to manually pull because it will not ever automatically pull because it doesn't want to overwrite your stuff.
Yeah. So if I'm like say working on something,
Yep.
I don't commit,
Yes.
and I just pull, it'll overwrite.
So if you have changes that are in your working tree, so like over here, you've got changes. Yeah. That aren't okay. There's some weird exceptions to it, but like for the most part, if you have changes there, you can't pull. You either have to commit them or do something called stash them. The other thing, GitHub Desktop is actually really smart. So it will do something called a pull with rebase, which is why it was letting me do it with these changes here before. So for the most part, you will never run into it. You can just do the pull with rebase, and that's fine. Basically what that does is, let's say you've made some changes, right? You're sitting here. It goes and grabs from remote and just sticks it underneath your changes. That's what a pull with rebase does. That's what a rebase is in general, is it takes some other changes and sticks them under where you are right now.
So it won't break anything, but there's still at least some logs. So
Yeah.
Got it.
Yeah.
Say if you had two working branches, and then one branch gets so far ahead of the other one, it's Does it remind you to just delete this one? Does it let you just delete a branch?
You can just delete branches. Yep. You can either do that. So if the branch has been pushed or published, then you can do that from GitHub. What's something that I can? Okay. I am going to be bad. We're going to log into my high school robotics team's GitHub, and we're going to go delete a stale branch. So here we go. This was last updated a month ago. It is 84 commits behind, right? They're not going to use this again. So we can come here, we can click this delete button. I'm not actually going to click it because I am a little bit nicer than that in case they needed something out of it. It doesn't delete it forever. It still has all the logs, but it keeps it from showing up and being annoying.
Pretty much, no matter what you do with GitHub, as long as you're not getting into messing with some silly command line stuff, you can recover just about anything you want to, which is a nice thing about GitHub, is that as long as you commit stuff and push them to the cloud, everything will always be there, and you can always recover stuff. So if you mess something up, if you corrupt a file, if you lose your entire laptop and you need to get all the project files back, you can get them back.
Yep.
So basically I'll show you, every single one in here has at least one, if not more, repositories sitting inside of it. So everything in my projects folder is backed up somewhere on Git. So that also makes it really nice because that means switching from my Mac to my desktop, I can just pull and then push. Or if I lost this, I can go on my iPad, I can pull and push. I can go on my desktop, pull and push. Yeah. Any other questions?
Thank you guys for coming.
Yeah.
Hopefully you learned something. If you're interested in robotics at all, join our Discord, come to our meeting. We're actually going to have one right now.